Hello, Mayong Buntag. For today, we are going to discuss another sorting algorithm or another sorting technique, which is selection sort. So let's now go to our IDE. But before that, let's discuss first what how bubble sort rather sorts data in the data or element. In bubble sort, it's going to compare the contiguous elements until it is sorted. So example, we have 23 is compared to 65 if they are not in order depending on depending on what you would like to achieve, if it's either ascending or descending. Example, in our case, we are going to sort them in ascending order. So 23, this one, will be compared to 65. You say, is 23 greater than 65? If it's false, then therefore there will be no swapping happens. Then is 65 greater than 10? So since it's true, 10 and 65 will actually be swapped. So this time, the 10 will take place, the position of 65, and 65 will be now in this position. So and then in that manner, 65 will now be compared to the the other element, which is 5, and then this is, let's say, 65 is greater than 10. Since it's true, therefore 5 and 65 will be swapped, and then after that, 65, we have here the 65 in this position. 65 is going to be compared in 37, and if it's true, since it's true, yeah, it's true. Therefore, they will be swapped. So therefore, we have here 65 and 37 right here, and then 65 right here, and uh, this is going to be the same process until until all the data are sorted, okay, in ascending manner. Okay, so that's how bubble sort does it. Okay, now in exchange sort, it's actually going to compare the element to the other or the rest of the other elements. Example, 23. 23 will be compared to the rest of the elements, which are 65, 10, 5, and 37. However, they are not in proper position, or let's say we want to sort them in ascending order. So as you can see, we have 65, 10, 5, and 37. This will be compared to the rest of the elements. Let's say 23 is greater than 65. Since it's false, there will be no swapping happens. Or then we have 23 is going to be compared by 10. So is it true? Yes, true. Then therefore 10 will replace position of 23, and then 23 will now take place of 10. So therefore, we have here now 10, and 10 it's now being compared to 5. Since it's true, 5 will now 5 and 23 will be swapped. So 5 here, we have 5 here, and then we have 23 here. Then all throughout it's going to do the same process until uh, until it is sorted. The thing here is that in exchange sort, every loop, let's say first loop is it assumes that the first element is already sorted. So in the second loop, the next element to that will be now compared to the rest of the element. So I mean errata, uh, 23 is after the first loop. This first element now in exchange sort is now assumed to be it's already sorted. So therefore, the next time, the next loop, it will not be it will not be compared to the other element. So it's going to assume already that it is already sorted. So next is it will now focus on the next element to that and then compare it to the other element. So in this time, we are going to uh, create another algorithm, which is or another sorting technique, which is selection sort. Now, in selection sort, it's actually for me personally, it's like a combination of uh, bubble sort and exchange sort. Only that it does not there's not much there is not much swapping happens. Okay, why? Because let's say we are going to take this same elements right here, right? So find this. All right. So in selection sort, uh, it it in the first loop it is going to identify first this one as the, let's say we want to sort them in ascending order. So this one is assumed to be the lowest value, and then this one is now being compared to the rest of the element. But this time, every time they are not in the proper positions or there is true evaluation, let's say 23 is greater than 65, that's false. 23 is greater than 10, that's true. So it's not going to swap that yet. I mean, it's not going to swap yet. It has to first identify, it has to get the index position of 10. And then 10 now will be used to compare. So this 10 now will be used to compare to the next, to the contiguous element, which is, let's say 10 is greater than, is it greater than 5? That's true. And if it's true, so since it's true, 5 will now take the lowest uh, position. So, but in that case, it's not being swapped. So after that, 5 will be compared to 37. Once it is evaluated to true, then since it's false, by the way, because 5 is not greater than 37, so 5 will take as it is as the lowest element. So that's the time after the loop, that's the time 20 this 5 is now, and 23 and 5 is now going to be swapped. So that's the only time the elements are swapped once it already recognizes or selected the lowest value. So it assures that this one is the selected value, this one, this index rather, and then that's the time it will swap it will swap it to the proper position. So in this case, when we have here 5, so it guarantees that the first element now is now being sorted. So the next loop will now take the second element, and then it will now be assumed as the lowest value, and then after that it will do the same process. So to do the implementation, we'll have here the same data or elements, and then we have let's have two loops. This time we are going to declare another, let's say, variable to hold the value, and then we are going to also let's say, since I mentioned about the sorry lowest value, so we are going to determine the lowest value. Okay, and then this time we will declare x and y, because this has to be declared outside of the loops, no, x and y. So will take the position for inner loop, sorry, outer loop, and then y for inner loop. So here, right here, we have x is 0, x is less than the length of the array. Okay, then we have x plus plus, and let's just copy paste this one. This will this will be y, and this will also be y and y. In this case, we'll have to combine. This is now what I've told you about, because it's like a combination of an exchange sort, no, combination of exchange and bubble sort. That's only for me now. So let's say for an instance, are going to start with one, because it gets to compare this one to this one, and uh, on the first loop, okay, and then on the second loop, this one to this one, something like that. Okay, now particularly we're gonna be using lowest, okay, this lowest value as the like meaning the we are going to get the index value, the index of this element in the first uh, element as the lowest value. Okay, so then after that, we are going to use this we call this one, this data, this variable, to compare. Okay, so let's say for an instance we have r, then let's say r x, okay, and then sorry, ry is going to be, which is this one, no, 23, going now to be compared if it's greater than the R lowest. Sorry. Mhm. So if this one is greater than the lowest value, so it says 23 is greater than the lowest value. So if it's false, yeah, if it's false, no, like that. So we have, because we are going to arrive, we want to arrive the ascending order. So this time, going to be if this element, okay, or might as well we are going to do this one na lang para it is uniform. R I. Okay, so the 23 is now being compared to the rest of the elements, but this time it's not going to swap, but rather it's going to get the lowest value, which is, let's say, after that it will get the y value. So whenever the element, whenever the element here is right here rather is there is true in every comparison, or in every comparing process, or yeah, comparison, it assigns the value, the index value, to the lowest value. Okay, so before this loop ends, it would determine now the it will guarantee rather that the after this loop, it will guarantee now that the lowest value is this one, this particular index. And that's the time after that is the swapping happens. So it's not going to always swap all the time. Every time it recognizes uh, there is there are actually elements that are not in the proper position. So this time we will use hold to get the value for like the lowest, just because that is always the case, okay, before we swap them. And then after that, the R lowest will be I mean R, yeah, so R lowest will be will have R, so which is the X, and then after that we have Rx is going to be compared to it's going to get the value from hold. Okay, so this time let's check if we are able to, this is outer loop, this is main, so para we are not we will not be confused. This time I'm going to create another loop to check if we are able to, uh, let's say we are able to sort the data in a particular order. So let's say we have z is less than r dot length, we have z plus z plus plus. Okay, so we're gonna be using or declaring an all variable, just like what we did before. And then right here we are going to use the option pane that show message dialog. Then let's use JText areas, what I have explained in the previous sorting technique. So we have here all right there. Yeah, I'm sorry for that. It should be in the outer part, and this will have all plus equals array d. Okay, so let's run the program. Then let's see if we are able to sort the data. So in this case, we are actually able to sort our data in ascending order. So now again, it depends on how would you like to compare, as long as the lowest value here right now. So it's either the ry here will be compared if it's less than to r lowest. It depends, no? So let's say for an instance, ry here, if it's less than 2 r get lowest y as the lowest value. Okay, now how is that possible? I mean, how it happens? What's the process of sorting selection sort? Sorting data using selection sort. So again, this would determine this one right here determines the for every loop it it will set that the this specific index is going to be the lowest value. So as this increments its value, it starts with 0, and then after this loop, after the first loop, this will be, since the x will increment by 1, so this time this the index of this one will be assumed to will be assumed as the lowest value, and then so on and so forth. So this will also increment by 1, so 2, 3, 4, and so on and so forth. So on and so forth. So let's now do a a what they call this one, a tracing. Okay, so when x is actually 0, when x is actually 0, let's use this one. Okay, right here. So when x is 0, and then so that's 23. So it means to say that the index of the first element is actually 0. So it assumes that 23 is the lowest, has the is the lowest value, but it gets the index rather than the value itself. So after that, you have it will be compared to y, uh, which is the second element, that is x plus 1, that is 0 plus 1, that is 1. The value of y is 1. So 23 will be compared to 65. I'm going to erase this one here so that I would be able to write. So we have here r, I mean, the value of our lowest is 23. So 23 is going to be compared to the value of ry, which is 65. So is it true? No, it's false. So since it's false, it's not going to execute this one. So most probably it's now going to uh, I mean, go to the inner loop, and then this time it's going to compare 23 to 65, 23 to 10. So this time 23 and 10 will be what they call this one, compared. And then if it's, since it's true, so is 23 is greater than 10. Since true siya, ang mahitabo is the this will be executed. In that sense, and in this manner, the lowest value is now going to take the index of 10. I mean, the lowest variable is now going to take the index of 10, which is the index of 10 is actually 2 because 0, 1, 2. So this would get the index. So our lowest value now is 2. Okay, so there's no swapping happens there. It's just the lowest value is now updated to 2 as an index because it recognizes that 2 is now the lowest, it's the lowest value, or yeah, it assumes to be the lowest value. And after that, it gets to compare the 5. I mean, this time 10 and 5 will be compared. So this time we have here 10, and then right here we have 5. 10 greater than 5. So since it's true, therefore, the lowest value will take the index of 5, which is the index of 5 is actually 3. Now, next to that is this 5 and 37. So we have here 5, which is the lowest value, and then 37. Since this one is actually false, it's not going to execute this one. In this sense, the y now becomes actually 5. So it's 5 great less than 5. It's false. Okay, I just forgot the ano, but that's the case, no? Because we just increment by 1, and it's compared to y to the length of the element, which is actually 5 less than 5. It's false. So since it's false, this time the last value of lowest is 3. So it is assumed now that the index 3 is actually it's actually the lowest value among all. So this time Since false, it will end having or leaving the lowest by 3 value. So that's the time it will now swap. So when it is now going to swap, it's only it's only going to swap once. Now I mean once per loop. Okay, so we have here the value of hold is going to be the lowest, which is 5. Okay, and then the value of lowest will be assigned, which is the value of lowest is 3, right? 3, index 3. So 3 will take 23 will take the position of 5, which is this time 5 and 23 will be swapped. So it's like exchange sort, only that this time around is saka pa siya mag-swap. And then we have here the Rx, which is in this case our x is 0. Yeah, so our x is 0. It's going to take the 5 as the value. So this time the updated value for our array is going to be 5, 5, 65, 10, and 23, and 37. Okay, when your x is 0. Okay, all right. So now when x is 1, let's say x is 1, so it increments by 1. So this time, the x is now 1, therefore it now becomes 1. So when x is 1, this is going to do the same process. So what do we have here is that we just copy this one, that we will not be mawala, no? So from here, 5 is going to be assumed already that it's already sorted because it sets na the lowest value is going to start with the index 1. So this time it's not going to include 5 anymore. So here 65 will be compared to 10. So 65 is greater than 10. So we have here 65 is greater than 10. That's actually true. Therefore, lowest value will take the index value of 10, which is actually 2. And then after that, 10 will be compared to 23. So 10 compared if it's greater than 23. So is 10 greater than 23? It's actually false. It's 10 greater than 37. It's 37. It's actually false, leaving the without leaving lowest as the the index. I mean, leaving the lowest to take the index of 10, which is 2 after this loop ends. Kasi when we reach here, the value of our y is 5 and 5 is less than 5. That's false. So after that, after this would end, this is the time the swapping process will be done. So this time, we have here the lowest value is 10, which is the lowest is 2. The index of 2 is 10. Yeah, the index of 10 rather is 2. So it gets the value, which is 10. And after that, what will happen then? Since we have array lowest, which is 2 this time, so it is going to be assigned by new value, which is the value of x, which is this time the value of our x is 1. So what's the value of 1? 65. So it's going to be 65 rather. So we have here now the whole, I mean the rx, which is r1, will take the value of 10. So this time it is now going to be like this. The value is uh, we have 5. We take the 5 and then 10, 65 will be swapped because 10 and 65 now are swapped. Then, sorry. And then we have 23 and 37 remains the same. So this time, let's say for an instance, we are going to, I hope you're not hearing the sound right there in my neighbor. It's actually they're actually making sounds like I don't know, but I'm using crisp noise suppression. I hope it's not being recorded. Not being recorded, I mean. So this time, when x is 2, this would become 2. Okay, so let's copy this one and take it right here. Okay, so this time the we are going to focus on this one 65. So 65 to the rest. So 65 is going to be compared to 23. Is 65 greater than 23? That's actually true. Therefore, what's the index of 23? It's actually 3. Then it's going to get the index of that, which is 3. So now 23 is now compared to 37. So is 23 greater than 37? That's actually false. So when it is false, what will happen? So it will not actually execute this. And then since we reach to this level or to this up to this point, the y now becomes 5. Is 5 less than 5? It's actually false. Therefore, what will happen? Leaves the lowest has the value of 3, which is the index of 23. By then, ang buhaton is it will take the lowest, the index, the value of that index, which is particularly 23, and then swap it to 65, the same, and then the array x, which is array 2, will take the value of 23. So in this case, 23 and 65 will be swapped. Okay, and sorry, what happened? Uh, it should be right. So this is 23, this is 65. Okay, when x is now 3, okay, what will happen then? So this will now become 3, this will become 3, and then after that we are going to take this one right here so that we have an updated value for our array elements. And then right here, since 3, it's going to be comparing the 23 and 65 and 37. So we have here 65 and then 37. Is it true? Yeah, yes, it's true. Therefore, it will take the lowest variable will take the index of 37, which is actually 4. Okay, so increments by 1 and y, it becomes 5. Then 5 is less than 5, it becomes false. Therefore, it leaves the lowest value to remain as the lowest value, which is 4. So this time, it is going to get the value, which value of the index value of the index 4 for lowest, which is actually 37. It is going to assign to hold, and then 65 will 65 is the the element that is going to be swapped, and have 37. So right there, what will happen then is we have a 5, 10, 23. Okay, as usual, it's already sorted. So we have 37 and 65. Now, for this, the index, this one becomes 4. Okay, so when lowest, when x is 4, other, so this one 4. So let's say we have here x is 4. It is going to take the lowest as the this one 37 as the value 4. And then actually there's nothing to compare, so we can actually do like -1 later on. Let's try, but yeah, so it's going to, because it's not going to, there's nothing to compare actually. We have 4, and then 4 plus 1 is like 5. 4, so 4 plus 1 is 5. This will become 5. So 5 less than 5, it's false. Therefore, nothing is going to be compared. I mean, this it's going to stop the loop. It leaves this one right here as our value. So actually, it stops from there already. We have our elements right here, the swapping values, something like this is how the our compiler traces it. Now let's try it's if we are able to, to let's copy paste this one. If we are able to have to read the same with our compiler. So right there we have that one, and then then let's try to run. Let's run the program. So we just lock one more. Sorry, I'm just excited. Uh, so we because we're live now. Okay. So now let's do this and do this and do this. So you have here 5, 65, 10, 23, and 37. So 5, 65, 10, 23, and 37. 5, 10, 65, 23, and 37. 5, 10, 23, 65, and 37. And then 5, 10, 23, 37, and 65. And then 5, 10, 23, 37. It's actually the same. So we have here one more time. It's actually because of this one, no? Because it's z less than 0 to this is 0 to 4. That's why we have another like that's the case actually. But actually based on our program, it's like it's already sorted at index during the third loop. Okay, so that is why we display that kind of display or output. It's because of this one. Okay, so now we can actually get to compare this by up here sorry, int start equals system dot nano time, and then we'll have no, we have to use long, and we'll have to have another probably right here, and okay, and then here time units is equal to and minus start. All right, so I guess that's it. And then, yeah, so let's run the program. And we have 195, 680. Let's have exchange sort. It's 840,000. Let's have bubble sort. It's 288. So let's rerun again for bubble sort. 194. Let's have exchange sort. 288. Okay, it varies because sometimes no, it's like that. But based on what we read, actually, this one is it's faster because it doesn't have that much swapping happens because it's only going to swap once there is once there is like what they call this one once there is only once it's already recognizes the lowest value. So the very reason maybe why it's displaying something like long parang time units is mas long. It's has it's not evaluated to become as efficient as it is because probably of this one. Yeah, let's try to remove this one. Okay, so let's try to remove this one right here. Let's try, and then let's run. So this time 2408 already. So let's do the same. Let's do the same for assume. Assume so exchange sort. So that's 2,800 plus. Then we have here it's 2616. Yes, only a small bit of 2397, 2676. That's it. So and then for bubble sort, we can actually copy paste this one right here, and then let's try if it's not yeah still yeah sorry because we don't actually delete or remove that one. So still going to be like still no uh, in our as you can see in bubble sort, no matter we remove the loop inside here, it's still going to do the efficiency is still too slow. It's very slow. while in the exchange sort and the selection sort, it's only a matter of 2,000 time units. Okay, 2,000 time units compared to exchange and bubble sort. So I guess exchange sort is a lot faster compared to the two. But if I get to compare it based on our like reading, something like based on our, and I like this, this one for me is a lot faster compared to exchange and bubble sort. Okay, so but again, we cannot evaluate. Our evaluation is not that accurate. So uh, this is the time you might be using the time and space complexity. All right. So I guess that would be all for today. Thank you guys for watching this video and have a great day. Bye bye.